Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 2 to the power of 24. So to solve this, I'm going to first start by rewriting 2 to the power of 25 as 2 to the power of 24 plus 1. So I have this minus 2 to the power of 24. And the reason I did this is because we want both of these to be the same. We want to have 2 to the power of 24s. So the best way of changing 2 to the power of 25 as 2 to the power of 24 times something is to rewrite this as 2 to the power of 24 plus 1. So now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So now 2 to the power of 24 plus 1 turns into 2 to the power of 24 times 2 to the power of 1. And I still have this minus 2 to the power of 24. Now, from here, what I'm going to do is factor out 2 to the power of 24, because notice how both of these terms have 2 to the power of 24 in them. So, I get 2 to the power of 24 times 2 to the power of 24 times 2 to the power of 1 divided by 2 to the power of 24 is just 2 to the power of 1. And negative 2 to the power of 24 divided by 2 to the power of 24 is just negative 1. So I get 2 to the power of 24 times 2 to the power of 1 minus 1, which is equal to 2 to the power of 24 times 2 minus 1, which is equal to 2 to the power of 24 times 1. And this is just anything times 1 is obviously just equal to itself. So this is just equal to 2 to the power of 24. Now, from here, I'm going to rewrite this as 2 to the power of 12 times 2. So, the reason I did this is because I can now use the property a to the power of m times n is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is equal to 2 to the power of 12 to the power of 2. And 2 to the power of 12, well, 2 to the power of 1 is equal to 2. 2 to the power of 2 is double of 2 to the power of 1, so 4. And 2 to the power of 3 is double of 2 to the power of 2, which is 8. So this pattern goes on, and I keep on doubling this. Until I reach 2 to the power of 12, which is equal to 4,096. So this is my value for 2 to the power of 12. So now I get 4,096 squared. Now, what most people would do, well, first of all, 4,096 squared is the same thing as 4,096 times 4,096. And from here, what most people would do is they would just multiply this like this. So they do 4,096 times 4,096 and use the conventional method to multiplying it. However, this method takes way too long, and it's really easy to make an error using this method. So instead, to more easily solve this, I'm going to rewrite this as 4,000 plus 96 times 4,000 plus 96. And now I can use the distributive property. So I get 4,000 squared plus 4,000 times 96 plus 4,000 times 96 plus 96 squared. Now, from here, $4,000 squared, well, this is simple because all we have to do is 4 squared, which is 16, and then 1,000 squared, which is a million. So a million has 6 zeros, so all we have to do is add 6 zeros to the end of this. So I get 60 million, it's 4,000 squared, plus 4,000 times 96. Well, 4 times 96 is 384, so then all we have to do is add 3 zeros to that. So I get 384,000, and then this should be 4,000. So plus, again, 4,000 times 96, which is 384,000, plus 96 squared, which is 9,216. So now all we have to do is add all of these up, which is fairly simple. So I get 16 million plus, let's first start by adding up 384,000 plus 384,000. So that's going to be 768,000 plus 9,216. And now this is equal to 16 million plus 768,000 plus 9,216, which is 777,216. And now for my final step, I just have to add this to 16 million. So we don't have to worry about the millions place, so I just get 16,777,216. So this is my answer to this problem. Now, if you haven't already, please make sure to subscribe and leave a like, because I have many more videos like this on my channel, which you guys can try to solve. And if you're up for challenges, I have a bunch of those as well. So please make sure to subscribe, and thank you. Bye. Alright, so in this problem, I have 2 to the power of x minus 3 to the power of y is equal to 7. So I want to find the values of x and y. So for my solution, if I have something in the form 2 to the power of x minus 3 to the power of y is equal to 7, I'm going to rewrite 7 as 4 plus 3. So now I have 2 to the power of x minus 3 to the power of y is equal to 4 plus 3. And the reason I did this was because 4 is the same thing as 2 squared. So now I get 2 squared plus 3. And notice how I have something in the form 2 to the power of number minus 3 to the power of number is equal to 2 to the power of number, and I also have 3 to the power of 1. Now from here, I'm going to group the powers of 2 together and group the powers of 3 together. So I'm going to subtract 2 squared on both sides. So I get 2 to the power of x minus 2 squared minus 3 to the power of y is equal to 3. And then I'm going to add 3 to the power of y on both sides. So then these two cancel out, and I get 2 to the power of x minus 2 squared is equal to 3 to the power of y plus 3. Now, for my left-hand side, I'm going to factor out 2 squared. So, actually, instead, I should say I'm going to divide by 2 squared. So, 2 to the power of x divided by 2 squared is equal to, well, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So that's the same thing as 2 to the power of x minus 2. And then I have this minus 2 squared divided by 2 squared is 1. And now this is equal to, from on this side, I'm going to divide by 3. So I have 3 times 3 to the power of y divided by 3. 3 is the same thing as 3 to the power of 1. So I get 3 to the power of y minus 1. And then 3 divided by 3 is equal to 1. So I get plus 1. Now from here, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 2 squared times 2 to the power of x minus 2, this is equal to 2 to the power of 2 plus x minus 2, and these two, and 2 and negative 2 cancel out, so I just get 2 to the power of x. So 2 squared times 2 to the power of x minus 2 is 2 to the power of x, and I have 2 squared times negative 1, which is negative 2 squared, and this is equal to 3 to the power of y plus 3. So I'm just checking if we distributed it, or sorry, if we factored out right, and it looks like we did. So now going back here, let me rewrite this. I have 2 squared times 2 to the power of x minus 2 minus 1 is equal to 3 times 1 plus 3 to the power of y minus 1. And notice how 2 squared, that's equal to 4, is an even number, and 2 to the power of x minus 2, well, 2 to the power of any number is even, and an even number minus 1 is going to be odd. So we have an even number times an odd number is equal to 3 is an odd number times 3 to the power of any number is an odd number, plus an odd number plus 1 is an even number. So you have an even number times an odd number is equal to an odd number times an even number. Now, what I'm going to do is I'm going to set the odd numbers equal to each other and then the even numbers equal to each other. So this gives me two equations. I get 2 squared is equal to 1 plus 3 to the power of y minus 1. And I also have 2 to the power of x minus 2 minus 1 is equal to 3. So let's first start with this equation. This is going to equal 4 is equal to 1 plus 3 to the power of y minus 1. And this means that 3 is equal to 3 to the power of y minus 1, meaning y is equal to 2. So the value of y is 2. Now for 2 to the power of x minus 2 minus 1 equals 3, I'm going to first start by adding 1 on both sides. So I get 2 to the power of x minus 2 is equal to 4. And now 4 is the same thing as 2 squared, so I get 2 to the power of x minus 2 is equal to 2 squared. And this means that x minus 2 is equal to 2. And if I add 2 on both sides, these two cancel out. And I get x is equal to 2 plus 2, which is 4. So my solution is x equals 4 and y is equal to 2.